Hey everyone, this video is on absolute value equations. So let's suppose we have this equation, the absolute value of x equals 5. By looking at this equation, what number could you substitute for x which would make this statement true? So without doing any work, the absolute value of what number would give you 5? Right, there's actually two answers. X equals 5 would work, right? Yes, the absolute value of 5 gives you 5. The absolute value of what other number will give you 5? Right, negative 5. The absolute value makes the number inside positive. So we have two answers. X equals positive 5 or x equals negative 5. So these absolute value equations will have two answers. You should put them in braces, negative 5 and 5. When you put two numbers or more into braces to show a solution, you should put them from smallest to largest. Okay, here's our rule or property. If you have the absolute value of ax plus b equals k, and k has to be a positive number, then that gives you two equations, ax plus b equals negative k, or ax plus b equals positive k. So two answers. It doesn't matter which one you do first, but you're going to do two equations. One of them you're going to leave the value that's a constant on the right hand side. One of them you're going to leave it positive, and the other one you're going to make it negative. Okay, so here's our first example. Solve the absolute value of 2x plus 1 equals 5. So you're going to make two equations. One of them you're going to make positive 5, and the other one you're going to make negative 5. And you're going to remove the absolute values on both equations. Again, it doesn't matter which one you do first. Here I put the positive value of 5 first, so 2x plus 1 equals positive 5, or 2x plus 1 equals negative 5. Now we just need to solve both equations. So let's start with the one on the left. First subtract 1 on both sides. That gives you 2x equals 4. And then divide by 2 on both sides. And that'll give you x equals 2. Now let's move over to the equation on the right. Same steps. Subtract 1 on both sides. So that gives us 2x equals negative 6. Now divide by 2 on both sides. And we get our second answer, x equals negative 3. Now we should put our two solutions inside braces with a comma in between. So there's our solution set, negative 3 and 2. All right, let's do another one for practice. You might want to pause the video and work it out on your own. Okay, same step. 3x minus 7 equals positive 17, and 3x minus 7 equals negative 17. I suppose I tend to do the positive one first on the left, and the negative one on the right. Okay, add 7 to both sides. We'll work on our first equation. That gives us 3x equals 24. Then divide by 3 on both sides. X equals 8. Now let's solve the equation on the right-hand side. Same steps. Add 7 to both sides. 3x equals negative 10. Now divide both sides by 3. And you can leave it as an improper fraction, x equals negative 10/3. Put our solution in a set. In set notation, the negative 10/3 is written first. Okay, here's another one with an absolute value. What's different here on this problem is that there's a number outside of the absolute value. So to use the property for absolute value equations, the absolute value must be by itself on the left-hand side. So therefore, what we need to do is add 3 to both sides before using the property. So we need to get rid of the 3 before we could separate it into 2 equations. If you don't follow this step, what will happen is one of your solutions will be correct, but the other one will be wrong. So if you only get one correct answer, you can only get half credit. You don't want that. So we'll follow the steps. Anytime there's a number outside the absolute value, we need to use our operations of solving equations to get that absolute value by itself. Okay, so add 3 to both sides. So now that we have the absolute value of 5x plus 2 equals 13, now we could separate it into 2 equations. So we have 5x plus 2 equals positive 13, and 5x plus 2 equals negative 13. Let's solve the one on the left first. Subtract 2 on both sides. Gives you 5x equals 11. Then divide by 5. X equals 11/5. Now solving the equation on the right. Subtract 2 on both sides. That gives us 5x equals negative 15. Divide by 5, and you get negative 3. So writing our solution set, negative 3 and 11/5. So on these two problems, we're going to solve by inspection. In the property that we gave in the beginning, k was defined to be a positive number. If k is a negative number, there is no solution. So looking at this problem, the absolute value of what number equals negative 7? The absolute value of any number is always going to be a positive. So there is no number that will work. So here's a note. The absolute value of x will be a positive number. There is no way that the absolute value of any expression can equal a negative number. Therefore, the solution is the empty set, or no solution. So you could just use that 0 with a slash through it, and that means no solution. Looking at example 5, same idea. The absolute value of 2x plus 5 equals negative 4. Again, there's no solution. As soon as you see a negative number on the right-hand side, and the absolute value is by itself on the left-hand side, no solution. There's no work to do. Okay, now we have this next example where it's equal to 0. It's not a negative number. 0 is actually neither negative nor positive. Well, if we try to use our property, 2x minus 9 equals 0, and 2x minus 9 equals negative 0, well, negative 0, that's just the same thing as 0. So we really don't have to worry about the one on the right. So we're only going to have one solution. So let's solve our first equation. Add 9 to both sides. It gives us 2x equals 9. Then divide by 2 on both sides. And we get x equals 9 halves. Again, on the right side, we don't have to worry about it. So our answer is only 9 halves. Okay, our last objective here. Solving equations with absolute values on both sides. 3 notes. 1, we're going to create 2 equations, dropping the absolute value symbols. Sounds similar to the previous examples, right? We made 2 equations and we got rid of the absolute value symbols. On our first equation, it's going to be exactly the same, just without the absolute value symbols. So on our first equation, we write it exactly the same, but remove the absolute value symbols on both sides. The second equation that we have, it's almost the same. We're still going to remove the absolute value symbols on both sides. However, we will insert a negative in front of one of the sides. I prefer to insert the negative in front of the right-hand side of the equal sign, but it actually doesn't matter. Okay, so it's still really the same process. What's different is that on the right-hand side, it's not a positive number. It's an expression. So on our first equation, we just leave it the same. And on our second equation, we put a negative in front. Because it's an expression, we're then going to have to distribute the negative on the right-hand side. Okay, here's our first example. So again, we're going to make 2 equations. The first equation, exactly the same, but drop the absolute value symbols. The second equation, almost the same, just insert a negative in front of the right-hand side. Because it's a 2x minus 7, put the 2x minus 7 in parentheses so that we could distribute the negative sign that will be in front. Okay, so it looks like this. First equation, 3x minus 8 equals 2x minus 7. The second equation, 3x minus 8 equals negative, and then in parentheses, 2x minus 7. Okay, now we'll solve the equation on the left first. We have x's on both sides, so subtract 2x on each side. Now we have just x on one side, x minus 8 equals negative 7. To get x by itself, add 8 to both sides. And that will give us x equals 1. On our second equation, distribute the negative first. Think of it as a negative 1. So 3x minus 8 equals negative 2x plus 7. The negative sign must be distributed. Now again, we've got to get x by itself on one side. Right now we have x on both sides, so add 2x to both sides. That removes the x on the right-hand side. We have 5x minus 8 equals positive 7. Then add 8 to both sides. That'll give us 5x equals 15. Now divide by 5. X is 3. So now we have our solution. Put it inside braces, 1 and 3. We'll do one more example. Absolute value of 5x minus 9 equals the absolute value of 5x minus 12. You might want to pause the video, try to work it out. There is a small difference in this problem. You'll notice when you work it out, one of the equations does not give us a solution. Okay, let's do it. First equation, 5x minus 9 equals 5x minus 12. First equation, exactly the same, don't change anything, only remove the absolute values. On our second equation, almost the same, we just have to insert a negative in front of the right-hand side. Okay, let's work on the equation on the left. We have x on both sides, so subtract 5x on both sides. But that creates a problem, right? The x's cancel out completely on both sides, and we do not have an x left in our equation. What remains is negative 9 equals 12, and we know negative 9 does not equal negative 12, so that gives us a no solution. So we did not get an answer for this equation. Let's move on to the next equation on the right. Distribute the negative sign. That'll give us negative 5x plus 12 on the right-hand side. Now we need to get the variable on one side. So the negative 5x on the right-hand side, we're going to add the opposite to it. So add 5x to both sides. That will give us 10x minus 9 equals 12. Add 9 to both sides. 10x equals 21, then divide by 10. And we do get a solution for this equation. X equals 21 over 10. So in this last example, we only got one solution. And that's because the coefficients were the same value on both sides. It was a 5x on the left and a 5x on the right. So whenever you see that, you'll know that you're only going to get one solution. But it didn't hurt to go through the process. Okay, that's the end of this video. Make sure you put your answer in braces, and then I'll see you here for the next one. Have a good day.